Welcome back, everyone. So as we can see, our load testing has completed, and let's click inside of it and let's view the results. So over here, you're going to see some failed instances and you're going to see some completed ones. And when an instance failed, it means that it was not able to load up the model. So maybe the instance was too small, so it had too small of a CPU or too few CPUs, or the memory wasn't enough. And if you click inside of it, you can see that the model returned 400 or 500 error codes. So for example, that's why the MLC5 4 extra large failed. That's why the MLC5.2 extra large failed. So, we have the MLC5 large that completed, the MLC5.extra large, and the MLC5.9 extra large. And over here, you have some of these that have no names, and I've actually raised the support to AWS. I've spoken with them, and it turns out that when you don't specify all 8 kind of instances that you want to test, then it will try random instances, but it doesn't give the name, so it's not really helpful. Because remember, when we set up our job, we selected these 1, 2, 3, 4, 5 instances to test. And by default, the inference recommender tests 8 different instances. And so, we only selected 5, so it tried to do 3 additional ones. But those 3 additionals failed, and it actually doesn't even show the type of instance. And this is an error on the AWS side, and I've raised the support. So hopefully in a few months, they're not too fast, so I'm not going to say a few weeks, but hopefully in a few months, they're going to resolve this. I know it's not a priority for them because it's not, mission critical, but it's just annoying because these instances are just random instances that AWS tried but failed. So that's just what you need to know about it. Okay. Now let's look at the completed ones. So over here, you see the instance count, and that means how many instances the load testing was done on. And we can see that it was done on a single instance. Now you see the model latency, and this is in milliseconds. So 1431 milliseconds is 1.4 seconds. And this means that, when the model was under the most stress, on average, it returned an inference in 1.4 seconds. And when I say most stress, I mean, the max invocations per minute. So over here, this column, the max invocations per minute, shows the maximum amount of invocations that it can handle in 1 minute. So if you look for the MLC5 large, you see that in 1 minute, it's 167. So that's the most amount of invocations that it can handle. Now, if you look at a larger instance like MLC5.extra large, you see that the latency was smaller, and you see that the max invocations per minute was also greater. As you can see, so in 1 minute, it's able to handle 335 invocations. Now, if you scroll down to this large instance, the MLC5.9 extra large, you see that the model latency is less than 1 second, so it's 867 milliseconds, and it can handle almost 1,500 invocations per minute. So this is very powerful. And now, this also shows the cost per hour. So as you can see, this very powerful instance, the MLC5.9 extra large, costs $2.10 per hour. And this column is an estimate. And it's actually kind of confusing in my opinion, because it says cost per million inferences. And in AWS, you pay for the instances that you deploy per hour. So it's not per inference. Okay. So, you pay whatever, it doesn't matter if you get 200 requests per minute or 5 requests per minute. When you use the MLC5.9 extra large, you're going to pay $2.10 per hour. This cost per million inference is just an estimate. So Sagemaker does an estimate as to, if you were to have 1 million inferences in, X amount of hours, it would probably cost you this much. But you shouldn't focus too much on this column because this is not too accurate. This is an estimate. If you had 1 million inferences, then how much it would cost. When you're doing cost analysis, you need to focus on the cost per hour, okay? Because that will give you the actual numbers that you need when you're doing cost analysis, okay? Now, you can look at the parameters that the model was set up with. These are just some basic parameters, I wouldn't give too much, thought to it. These are just some default Sagemaker parameters that you can view. And yeah, so this is what you can do. You can look at the completed jobs and, based on your company's needs, you can be like, okay, do we want to handle 1,424? Do we need to handle 1,424 invocations per minute? Or can we go with something cheaper that can handle 335 invocations per minute? And that will cost, a lot less. So this is the kind of cost analysis that, you're going to have to do with your bosses or your managers. And trust me, this is going to level your career so much, because oftentimes it's so hard to gather actual information on, how to load test endpoints and what the cost will be. So, you have third-party tools like Locust where you can do load testing, but it's not as accurate and the results are not shown as clearly as over here. And you can't compare the results as easily. And one other thing I wanted to show you, if you scroll down, you can look at some input configurations, what model you want to use, the application type, where the benchmarking payload that we created is. And if you scroll even more down, you can come over here, and for the 3 instances that completed, so the MLC5 large, MLC5 extra large, and MLC5 9 extra large, you see you have the graphs here. So you can see that as the load testing happened, you can see how the model latency, for example, you see that for the instance metrics, I have model latency selected. You can see how the model latency increases, okay, as the load test happens. And over here, you see this is 1.23 microseconds, which is a lot less than 4.07 microseconds, okay? And these are just, microseconds. They're a millionth of a second. So over here, this 4.07 means 4 seconds. This 1.23 microseconds mean 1.23 seconds. So at worst, the model latency was, for this one small instance, it was in this instance, it was 4 seconds because it was load tested to the max and probably it failed at this point. So, the model was like, okay, we can't do anything past that. And that's why you see it scales down after that and it continues the load testing with, less invocations per minute. So this is how you can compare the model latency of each model during load testing. So as you can see for the MLC5 9 extra large, the latency never went above 1.23 microseconds. Now, you can drop down and you can select, for example, CPU utilization. As you can see, the CPU utilization during load testing, you can do GPU, but remember these instances, the C families, so the ML.C5 family, they don't have GPUs, so that's why we don't have GPU utilization. You can select invocations per minute. So as you can see here, we have at most the 171 invocations per minute. And if we go back up, we see that it was able to handle 167. So, the load testing probably realized here at 171, over here 172, that, okay, it's not able to keep up that many invocations per minute. So it has to do a little less. And, you can look at this one. This can handle more invocations per minute. Now, this one can handle 1,420 or almost 1,420. As you can see over here, the invocations per minute is 1,424. And if we go back, that's the max invocations per minute that the model can do without failing. So it's over here. And now you can also select memory utilization, and you can expect the memory utilization to increase as the load testing happens. And so this is a very good and very easy way for you to create these charts and show it off to your managers, because I guarantee you that they will absolutely love it, because it will make their decision a lot easier when they, bring it up to stakeholders. They can be like, okay, this is the max invocations that we can handle. This is the maximum model latency that you will encounter. So it's very easy for them to make the decision. And that you have these built-in graphs over here that you can use. You can zoom in on them if you want to. So you can do a lot of things. And this will truly help you become a better machine learning engineer, because not only are you able to deploy your model, you're able to give a great recommendation as to, what kind of instance you should deploy it on and what kind of instance is able to carry your model with the appropriate invocations per minute, model latency, and CPU, memory, GPU utilization, okay? So I hope this was useful, and I will see you in the next video.